Hello, and we're going to differentiate inverse trigonometric functions. We have ddx of arcsin x, which is a standard differential result, and it says is equal to 1 over the root of 1 minus x squared. ddx of arccosx is minus 1 over the root of 1 minus x squared. And finally, the differential of arctanx is equal to 1 over 1 plus x squared. Now, it said you should learn these results, but also be able to derive them as in the example above. So let's see how these derivatives are obtained. So let's do the math. So for first one, y is equal to arcsin x. Now, let's let multiply or apply sine to both sides. If that's the case, we're going to let sine of y is equal to x. Now, we're going to use a technique of implicit differentiation. Use implicit differentiation technique. So we're going to differentiate both we're going to differentiate both sides of the equal sign, and if we do that, we're going to get cos y dy dx is equal to 1 ddx. So we want dy dx on its own, so dy dx is equal to 1 over cosine of y. But you can say, well, hold on, we need a link between the arcsin x that we have in the question and the answer, what we've attained as the cos of y. Well, now we're going to use standard identity. So use sine squared y plus cos squared y is identical and equal to 1. And of course, since we said let sine y is equal to x, we need the identity rearranged so that we have cos y as in our denominator. So let's do that. So we've got cos squared y is identical equal to 1 minus sine squared y. Just a bit of algebraic manipulation. We want cos y, however, so because that's in our denominator or in our answer, cos y is equal to the root of 1 minus sine squared y. Well, that helps us how? Well, since we wrote that since y is equal to x, this will imply that the cos of y will be identical and equal to, and now here's the key, we just substitute x for sine squared y. Since sine y is equal to x, it's got to be 1 minus x squared. And that's nice because that means our differential of arcsin x is dy dx is equal to, and now what did we have? We had 1 over cos y, but cos y is the root of 1 minus x squared. And this is how we do. Now, what about the differential of arccosx? Let's go to another page and let's use the same technique. So y is equal to arccosx. And this should be easy if we apply cosine to both sides. So we've got cos of y is equal to x. And again, implicit differentiation says that differentiate cosine, we get minus sine of y dy dx. dy by dx is equal to 1 ddx. So, of course, similarly, like before, dy dx is equal to minus 1 over the sine of y. Again, we want a link between sine y and arccosx, and that link will be given by our identity. So again, we use sine squared, use sine squared y plus cos squared y is identical and equal to 1. But since we let cos y equal x, and we got sine y in our denominator, we need to find it in terms of what sine y is. So we have sine squared y is identical and equal to 1 minus cos squared y. And similarly, we want sine y, so sine y will be equal to, or identical and equal to, the root of 1 minus cos squared y. But since we have, and it's exactly the same as before, since cos y is equal to x, this implies that sine y, again, we're going to substitute cos squared y for x squared, is equal to 1 minus x squared. So, therefore, the differential of arccosx is minus 1 over 1 minus x squared. And finally, arctan x, let y is equal to arctan of x. Again, apply tan to both sides. We're going to have tan of y, yes, is equal to x. And the differential of tan y, of course, is sec squared. Sec squared, using implicit differentiation technique now, sec squared y will be dy dx. Dy dx will be equal to 1 using implicit differentiation. Now, if I use the identity I've been using before, I've got sine squared y plus cos squared y is identical and equal to 1. But if I divide everything by cos squared y, cos squared y and cos squared y, I'm going to end up with, well, that gives me tan squared y plus 1 is identical and equal to sec squared y. So completing this now, getting dy dx by itself, dy dx is equal to 1 over sec squared y. Now, using the identity, again, I said tan y is equal to x. So if tan y, since tan y is equal to x, since tan y is equal to x, I'm going to substitute that in for tan squared. So that will give me x squared plus 1, which is equal to sec squared. Therefore, I can say this implies that the differential of y is equal to arctan x is 1 over x squared plus 1. And that's it for your 3 differentials of your trig IDs, inverse trig IDs. So, and that's how you show it. Okay?